Now we explore residual plots. A residual is the actual score minus the modelled score. If we look at the raw data, let's say the modelled value was, for this particular observation, was 0.1, this one here is 0.3, this one is 2, this one is 0.6, and so on. The residual is literally the actual value, which was 0, minus the modelled value. So the residual here is negative 0.1, negative 0.3, negative 2, negative 0.6, and so on. If we had an example where the actual was something other than 0, let's say this one here where the actual is 2, the modelled value might be 0.6, say, in which case the residual is 1.4, and so on. Obviously, the smaller the residuals, the better the model, because it means that the modelled values lined up closely with the actual values. Apart from small residuals being desirable, we also want the shape or pattern or distribution of these residuals to conform to what we expect, given the error distribution setting that we chose in the workspace settings page, or the error distribution that the workspace wizard chose for us. If we chose a normal error distribution, we expect the residuals to have a bell-shaped distribution centered at 0, and the shape of the residuals should be independent of the modelled value. That is to say that the bell curve might range from about -1 to +1, whether the model predicted a score of 0.5 or 5.5. Other error distributions, such as the Poisson distribution we selected, aren't so simple. In the case of the Poisson, we expect the shape of the residuals to become more spread out as the modelled prediction increases. We can analyse the residual distributions by clicking Residual Plot in the GLM menu. On the left axis, you can display the raw residual, the Pearson residual, or the deviance residual by selecting from this drop-down menu. Now the raw residual is what we showed before, which is simply the actual minus the modelled value. The Pearson and deviance residuals are modified versions of the raw residual that attempt to normalize for the expected pattern in the residual cloud given the chosen error distribution. Now the axis on the bottom here can be chosen from selecting from this drop-down menu. On the bottom axis, we can plot the residuals against the linear predictor, or the sum of the betas, the expected value, which is the linear predictor run through the inverse of the link function. We talked a little bit about that in the scoring code video, or plotted against the actual response value. Now each dot on the scatter plot is a case or a record in the data. However, it's been capped at 1000 points in order to make it a bit more readable. The points have been randomly selected from the data set. If the distribution of points seen here displays bizarre patterns, like including weird outliers, then you might want to think about changing the error distribution in the workspace settings. A detailed lesson on how to interpret these plots would take many videos. However, here are some brief pointers to keep in mind. If you chose an additive model or a normal error distribution, then the residuals should be a cloud of points with no pattern at all. This is roughly a cloud of points with very little pattern at all. If you see a pattern like a fanning out, like a funnel, like a narrow cloud of points here fanning out to a very wide range of points out here, then the normal error distribution was not appropriate. However, if you chose a Poisson or gamma distribution, then when you're plotting the raw residuals, i.e. the residuals here, then the cloud of points should fan out like a funnel. Now the Pearson residuals, and even more so the deviance residuals, should strip out any prior shape that might be present in the raw residuals. So, for example, if you selected a Poisson distribution and we expect there to be a fanning out of points in a funnel-like shape, then the Pearson and deviance residuals should strip that out or normalize for it, so that when you select the Pearson or deviance residuals, instead of having a funnel-like shape, it should revert back to a cloud of random points. However, if the response is simply 0 or 1, such as when you're modeling a probability, then the residuals will pretty much just form two lines. This is because whatever the modeled probability is for a record, either the actual outcome will have been a success or a failure. It'll be 0 or 1, nothing in between. So there'll just be two lines that appear on the chart, and there'll be nothing much to interpret in the residual plot for success or failure models. This brief list can't hope to do justice to what actually is quite a complex topic that requires experience and judgment to interpret. So if you're ever looking at a residual plot like this and you're a bit unsure what it means, or whether the shape that you're seeing could mean that your model has been compromised or incorrect settings have been chosen, feel free to email admin@preddle.com to ask any questions. Now, if you recall from the import settings page, this particular model is using a Poisson distribution. The deviance against fitted values or predicted values shows mostly a cloud. So the model assumptions are probably okay.